This problem, given a list of anagrams, they can join or they can form a group if their positions with character difference is less than 2, less than or equal to 2. Less than or equal to is what it is really. So you can have at max 2. Just correct here. With any of the member in that group. You need not have that character difference less than or equal to 2 with every element in the group. You can join in the group if you find one of the connection. If you find a connection with any of the strings, any of the anagram, any of the anagram which is there in that group, string or anagram, whatever it is. Check how many groups are there. See, we have 4 anagrams here. This is a list of anagram with the 4 strings. So all these are containing TARS, 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 TARS. So the letters are same, but their positions are different. If you take TARS and RATS, S and S are in same, they are in same positions, no difference. A and A are in same position, no difference. But R and T at same position, R and T are different. At same position, R and T and R are different. So it has 2 positions where the characters are not alike. So you can connect if I number 1, 2, 3 and 4. From this you can connect 1 plus 2. So they 1 and 2 will be in a group. And let's check with 2 and 3. R8. Here is a error. Here is error. This is alike. This is alike. So you have 2 errors, 2 corrects. The maximum error possibly is 2. You have errors is 2. So you can connect 2 and 3 as well. So you can add 3 also to this group. Now let's check. Let's try whether we can add 4 into this group or not. A and S different. R and T, they are different. T and A, they are different. R and S, they are different. You have 4 errors. Between 4 cross 3, you have 4 errors. Let's try whether 4 can be matched with 2. STAR, RATS. This is an error, S and R. TI is an error, AT is an error, RS is an error. So 4 cross 2, there are 4 errors. Now what left is 4 cross 1, same star and TARS. So S and T there is an error, T and A there is an error, AR and there is an error, R and S there is an error. So this also gives 4 errors. So that means this 4 will not join with any of other strings. 4 will not join with 3, 4 will not join with 2, 4 will not join with 1. So when these 3 forms a group, when these 3 forms a group, 4 will be a standalone string, which will be a different group. So the number of groups we can form out of these anagrams is 2. This is the solution you have to find out. So how will you proceed with this problem? You can create a disjoint set. You can create a disjoint set, and in disjoint set, the connection criteria, you have to keep as the difference in errors as less than 2. Difference in erroneous positions less than 2. Erroneous position means the positions where the characters are different less than 2. So you will be able, in a disjoint set, you will be able to connect 1 and 2 and 1 and 3. So together they will form a group. Then you will initialize every string as an independent group. So at the end, star will be continuous independent. Rest of them will join in a group. So the correct solution is the appropriate usage of joint set, where the connection criteria is a number of positions where the characters are different is less than 2. So let's see the code and understand it in more detail. So you need a disjoint set to be created first. Disjoint set is a class. We'll have a parent array. Resize the parent array. to the size of n, initialize them with parent as themselves. Now you create a find method to check who's parent of certain element, parent of I. So I not equal to parent of I. Parent I equal to find of x. This means current the parent which is listed at your index is connected to some other node in the list of parents. So you have to figure out the root and return it. Otherwise, if it is a root, if your current element is root itself, then return that. Now you have to form your join operation. You will be joining x and y. Find the parent of x. Find the parent of y. If their parents are equal, that means they are already connected. If they are not equal, connect them. Parent of p equal to q. Then return it because we did a new operation. So this is your disjoint set. Instead of doing find, I will make disjoint set. Now initialize your disjoint set with a number of words you have. Let me initialize the number of words you have as words.size n. Now you need a function to check whether two words are similar or not. It will be a boolean similar string s string t. Let us pass them as reference. You need a counter. S of I not equal to t of I and counter need to be initialized to 0 plus count greater than 2. Return false because they are not similar. Or you can return true. Similar means the number of positions where they are different is less than 2. It's disjoint set. So go through all letters, all words, all pair of words. That will be the correct term to use. And join both if they are similar. If similar of I and j, join them. Now you have joined. What's the problem with? Okay, this is heads of I sub. So these are the two things. Okay, we need to construct it. Now you have to return the number of groups from your disjoint set. This group variable has to be defined at your disjoint set. Initially, it will be initially you will have n groups. When you make a connection, here we are making a connection. it will decrement groups, whatever it is. Yeah, this way, this way you have solved your problem. If words are matching each other, then you simply connect them. Otherwise, you leave them. You leave and proceed to the next. So here we have the same example we have discussed. So it was giving two groups. Let's try whether it is giving two groups or not. It's giving solution as two groups. So the answer is correct.